Alright, let's go through this formula. First and foremost, let's fill in the totals. So for Twitter we have 13, Facebook we have 4, Instagram is 13. For the males, there are 14, female there are 16, and there is a total of 30. So the probability of a student preferring Facebook is going to be 4 out of 30. The probability that the student is male and prefers Twitter is males preferring Twitter 7 out of 30. Now, the probability that the student is male or Instagram, so we can use the addition rule. Probability that they are male plus probability that they prefer Instagram minus the probability that they are male and prefer Instagram. So that's going to be 14 plus 13 minus 5, which is going to give you 22 out of 30. So, question number 4. The 10 mini footballs in a box. 5 say Dallas, 2 say Washington, 2 say New York, 1 says Philadelphia. That gives us a total of 10. So if we draw the tree diagram, just look at part of it. So the probability that the first ball is Dallas is going to be 5 out of 10, Washington 2 out of 10, New York 2 out of 10, Philadelphia 2 out of 10. So if it's without replacing, the second time we draw, there's only going to be a total of 9. So the probability of Dallas, if Dallas is first, is 4 out of 9. Washington, we still have the 2, so 2 out of 9. New York 2 out of 9, Philadelphia 2 out of 9. If Washington is drawn first, then the probability of Dallas is still now 5 out of 9. The probability of Washington changes to 1 out of 9. The probability of New York is 2 out of 9, and Philadelphia is 1 out of 9. New York will have the same tree as Washington. The only difference being Philadelphia is going to have 5 out of 9 for Dallas, 2 out of 9 for Washington, 2 out of 9 for New York. And since Philadelphia only has 1 ball, that's not an option if it's drawn first. So your question asks you first and foremost the probability of Dallas, Washington, or DW. So that's going to be 5 tenths times 2 ninths following the branch. 5 tenths times your 2 ninths gives you 10 out of 90. So now, the second part asks the probability of at least 1 Dallas ball. So now we need the probabilities of Dallas, 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 New York, Dallas, Pennsylvania, Washington, Dallas, New York, Dallas, and Philadelphia, Dallas. So we find all those individual probabilities, and then you have to add them all up. So you have them all up. Probability of at least 1 Dallas ball is going to be 70 out of 90. Okay. Now, let's take a look at question 5. So we have the probability of A, B, and A and B. So again, we can use the addition rule for the 4, which is going to be the probability of A plus the probability of B minus the probability of A and B. So that's going to give us 0.5 plus 0.2 minus the 0.15. So that's going to be 0.55 is the probability of A or B. So independence in part B, you can use the multiplication rule, which tells us that probability of A times the probability of B is going to be equal to the probability of A and B if they are independent. So in this case, 0.5 times 0.2 is not equal to 0.12. So no, they are not independent. P of A times P of B is not equal to probability of A and B. So your conditional probability, which you should have watched the video last class about that. Remember, the given will not always be B, but whatever is given is always going to be in your denominator. So you have the probability of A and B divided by the probability of B. So in this case, 0.15 divided by 0.2, which makes our probability of A given B 0.75. Okay, now let's move on to a notes for 4.7. So first and foremost is the louder read here stuff you already know. You know the and the or, and or is your addition rule. And your conditional probability. Take a moment, make sure you have all of this down, pause the video if necessary, because I'm going to move on. Okay, but again, all of this is stuff that you already should know. Mutually exclusive is the same as disjoint. Yes, things are mutually exclusive. They cannot happen at the same time. And the probability of A and B is equal to 0, which means it's disjoint. If A and B is not equal to 0, they are not disjoint. Complements, they have to be mutually exclusive, and the probabilities add up to 1. I'm pretty sure that's going to come up on your quiz and test. Independence, again, we use the multiplication rule. So it cannot be mutually exclusive and independent at the same time. So look at our first example. We got 200 people surveyed about where they live and what football team they cheer for. So the probability of being a Cowboys fan and live in DC is going to be 16 out of the total 200. Okay? The probability, so you're looking at B, that they are a Washington football fan given they live in Dallas. So given that they live in Dallas, again, we're only going to look at this column because that's what's given. So the total now is 103. Remember, Washington football fans, it's 9, so that's going to be 9 out of 103. And part C are living in DC and being a Washington fan independent. So we need to see probability of living in DC and being a Washington football fan is 74 out of 200. So, in order for it to be independent, 97 out of 200 times 83 over 200, that product would have to be equal to 74 over 200, which it is not. So, no, it is not independent for that reason. Alright, let's take a look at the next example. There we are. Okay. So you see the table. So if we choose a degree, what is the probability that person is a woman? So there are 856 total women. With the total altogether of 1,626. So the probability that the person is a woman is 856 over 1626. B, given that the person chosen received a professional degree. So again, I'm only going to look at this column. So now my denominator is going to be out of 74. So the probability that the person I choose as a woman is 30 out of the 74. Okay? So the next example, the tree's already done for you. You just have to put your probabilities in. So there are 3 blue marbles and 5 red, which gives us a total of 8. Monica's picking the marbles without replacing. So the first time through is going to be out of 8. Second time through should be out 7. So the first time there are 3 blues, so that's going to be 3 out of 8. And 5 red, so that's going to be 5 out of 8. And then when we draw again, if blue is first, the next is going to be 2 out of 7, and red will be 5 out of 7. If red is first, the next one being blue is going to be 3 out of 7, and the probability of getting red again is 4 out of 7. So the question is asking the probability of each outcome, so we need to multiply the branches. So blue is going to be 3/8 times 2 sevenths. Red is going to be 3/8 times 5 sevenths. Blue is going to be 5/8 times 3 sevenths. And red is 5/8 times 4 sevenths. So there are your probabilities for each outcome. The next example, rather. Take a moment, pause the video, and try it on your own. Hopefully you were able to at least get the tree correct. Okay, so there are 4 red seeds and 5 white. So it's 4 ninths out of 5 and 5 ninths respectively. Again, drawing without replacing. So second time we draw out of 8. So the probability that you have 1 of each color. So the probability of red, white is going to be 4 ninths times 5/8. And then the probability of white, red is going to be 5 ninths times 4/8. So you get 20 out of 72 for both. Add them up. And the probability of getting each of one color is 40 out of 72. Again, pause the video if you need time to copy stuff. Okay. The next 2 examples are other examples of trees. If you check Blackboard, those will be there. You need to copy them on your own, and if necessary, you can copy them from Blackboard. Correct? Make sure you see me outside of class, be it out of school or board or block, if you have any questions. All right, let's run through this last example. All right. So we got 3 factories, and I'm just going to call them 1, 2, and 3. Okay? So factory 1 produces 25% of the shoes, so that's 0.25. Factory 2 produces 60, so that's going to be 0.6, and factory 3 produces 15%, so that's 0.15. Now, 1% of the shoes produced by factory 1 are mislabeled. So mislabeled and C for correct. So that's going to be 0.01 of mislabeled, which means 99% are correct. Factor 2, 0.5, that's going to be 0.005 are mislabeled, so 0.995 are correct. And for 3, we got 2%, so 0.02 mislabeled, which means 0.98 or 98% are correct. So the question is asking us the probability that the shoes are mislabeled. So the probability that they're from factory 1 and mislabeled is going to be 0.25 times 0.01. The probability that from factor 2 and mislabeled is 0.6 times 0.005. And the probability that from factor 3 and mislabeled is 0.15 times 0.02. Again, following the branches. Okay? From 1, mislabeled. From 2, mislabeled. And from 3, mislabeled. So the probability that it's mislabeled is going to end up being 0.0085 if you add all those up. Okay? So make sure you get worksheet 4-7 complete. And again, see me if you have any questions.